Have you ever made a crucial decision, only to wonder if you got it wrong, or perhaps missed something important? In the world of machine learning and statistical modeling, making the right call is paramount, but there is always a risk of error. So, how do we quantify and understand these potential missteps? Type 1 and Type 2 errors are fundamental concepts in hypothesis testing, representing two distinct ways our models can be incorrect. A Type 1 error, also known as a false positive, occurs when you incorrectly reject a true null hypothesis. Conversely, a Type 2 error, or a false negative, happens when you fail to reject a false null hypothesis. These errors stem from the inherent uncertainty in statistical inference, where we use sample data to draw conclusions about a larger population. When we set up a hypothesis test, we establish a null hypothesis, which is a statement of no effect or no difference. We then use our data to try and find enough evidence to reject this null hypothesis. The probability of committing a Type 1 error is denoted by alpha, also known as the significance level. The probability of committing a Type 2 error is denoted by beta. There is often an inverse relationship between these two types of errors, meaning that reducing the likelihood of one can increase the likelihood of the other. Understanding these errors helps us design and evaluate machine learning models more effectively. When training your models, you can consider how to adjust thresholds or weights to prioritize minimizing one type of error over another, depending on the specific problem. For instance, in a medical diagnosis model, you might want to minimize false negatives to avoid missing a serious condition, even if it means accepting a few more false positives. The implications of these errors vary greatly across different domains. For example, in fraud detection, a false positive means flagging a legitimate transaction as fraudulent, causing inconvenience but not financial loss to the system. However, a false negative in fraud detection means failing to catch actual fraud, leading to direct financial losses. Similarly, in spam filtering, a false positive might move a legitimate email to spam, while a false negative lets unwanted spam into your inbox. Ultimately, recognizing and balancing Type 1 and Type 2 errors is crucial for building robust and reliable machine learning systems. It helps you make informed decisions about model performance, choosing the right metrics, and ensuring that your model's predictions align with the real-world consequences and costs associated with each type of mistake.